Okay, we're looking at mixed exercise 7 from the first year core textbook. I'm on question 4. So this is the first exam question, but actually it's really similar to the previous one. It's just the wording of it. So for A, you could, they haven't said use factor theorem, which they often do. So one method would be to divide this cubic by x minus 3 and show that there's no remainder. But then, to be honest, that's to be honest more effort than 2 marks should be, and you're kind of answering part B if you do that. And the other thing we've got to watch out for is quite often on these questions it will say to use factor theorem, plus it's the easiest method. So factor theorem is where if x minus 3 is a factor, when I substitute 3 into that cubic, I am expecting an answer of 0. So what I would need to show is firstly some working that I am substituting in x is 3. And be careful, it's not x is minus 3. Okay, so just show, so that should actually be enough, but I'm just going to show an intermediate stage as well. So 2 times 27, 2 times 9, 17 times 3 and 15. And it's worth just double, I'm going to stick that to my calculator because obviously if that doesn't equal 0, I know I've just done something silly with my calculating, it does. Okay, so, and you don't need to sort of go in depth as to why factor theorem works, but you do need to write a conclusion. So x minus 3 is a factor, okay? So that seems about right for 2 marks. Okay, so then they ask us to show it, or sorry, to find those missing values. And one thing you can do is, seeing as we know x minus 3 is a factor, so there's no remainder, we can actually say what capital A and capital C are really easily. Capital A has to be 2, because we know we're supposed to get 2x cubed, and capital C has to be minus 5, because we know when those brackets are expanded back out, it should be plus 15. So you can get both of those without any working. To get B, you can either do it by inspection. So let's try that first, because this is going to be quickest, or you can just do the division. So if I'm doing it by inspection, let's write out more question. Okay, so I've already said what A and C are, and that's by inspection. So by inspection just means basically sort of spotting it. Okay, so let's just go over again how I knew those. So the reason I know that A is 2 is because when I expand the brackets back out, x times the ax squared is going to give me my only x cubed term. So for that to work, that must be 2x squared. So what I'm going to do, just to save a bit of effort, I'm going to fill those in as we get them. Okay, so I can straight off say that has to be 2, and then by similar logic, I can say that, let's get that out of the way, I can say that C, so the minus 3 times C is going to be my only constant. Yeah, everything else will be will have an x in it. So that's the only thing that's going to give me the constant term. That must be 15, so C must be minus 5. Okay, so they're the 2 straightforward ones. Right, slightly harder to find B through inspection, but it's certainly still doable. So to find B, I can either look at the x squared or the x term. So I'm going to look at the x squared term. So x squared is supposed to be minus 2x squared. So far, let's use the highlighter there. So far, I've got minus 6x squared. So if I were to expand these brackets back out, that's going to give me an x squared term. I'm also going to get an x squared term when I do x times bx. So that would give me bx squared. And they would be the only 2x squared terms. So together, they need to equal minus 2x squared. So that must be 4x squared, which means b must be 4. Okay, so I'll fill that in, and then we'll have a think about the minus 17x, because we can just use that as a check, hoping that the yellow is showing up enough. Okay, so if we then, let's think about the 17x. We haven't referred to that at all, but we can just use that to check that value of 4 is correct. So let's use a little bit of blue. Okay, so if I look at the 17x, if I go back to the right-hand side, where am I going to get an x term? Well, I'm going to get an x term from the -3 times the 4x, and from the x times the -5, and yeah, looking good. Those two would give me -17x, so I can just use that as a bit of a check. Okay, so that's us done. Yeah, A is 2, B is 4, and C is -5. Your alternative, if you sort of weren't feeling too happy about that, would just be do the full division. So grid method or the algebraic long division. So x -3, so let's quickly whip through this because it's going to give us the same values as we got before. So I'm looking back to this. So this needs to be 2x cubed. That's going to be my only cubed term. So that would need to be 2x squared. So 2x squared multiplied by 3x gives me -6x squared. I'm supposed to have -2x squared. So that's going to need to be a +4x squared. For that to be +4x squared, that's going to need to be 4x, so they multiply to give 4x squared. If that's 4x, the 4x times the -3 is -12x. So if you follow through the first method, you can see we're getting all the same sort of values or same expressions, just laid out differently. So now I'm looking at the x term. So the x term is supposed to be -17x. So if I've got -12x, I need another -5x. If that's supposed to be -5, so if that's supposed to be -5x, that must be -5, so that when I multiply it by x, I get -5x, and the -5 times the -3 gives us the 15, so that's just showing it works. Okay, so I get the same three values, whichever way I lay it out. Okay, I'll quickly check those. I can't see any where we could have gone wrong. Yep. Yes, so just be careful. I mean, they're just giving you the bare bones of the method. If you just wrote that for part A in an exam question, that wouldn't be enough work, and you need to show that you have substituted in x is 3. So this isn't a mark scheme, this is just sort of a quick check that your method's correct.